The Isle of Skye is renowned for its mountainous cliffs, windswept moors and rugged shorelines. Hidden on one of its wild and remote shorelines is evidence of another time and another place. A place that was much warmer and more humid than it is today. A subtropical place where 167 million years ago the dinosaurs left their footprints. Today, that place is Prince Charles's Point, a bay and rocky precipice situated on Skye's Trottenish Peninsula, a place that was named after Bonnie Prince Charlie, who briefly hid here in 1746 during his flight across the Highlands after his defeat at the Battle of Culloden. Since then, we've gone on to discover that Prince Charles's Point was in fact a hotbed for dinosaurs, with 131 dinosaur footprints recorded to date, representing large meat-eating theropods like Megalosaurus, the ancestors of T-Rex, to those lumbering giants, the long-necked plant-eating sauropods, all scattered across this vast fossilized rippled surface, the margins of this prehistoric lagoon. And when you look at these ripples today, it's just amazing to think that they're 167 million years old, because they just look like they've been made yesterday. And that's one of the thrills of coming to this location, is seeing all these footprints in a frozen moment in time, and it's just always surreal for me. So my name is Tone Blakesley. I'm a Masters graduate from the University of Edinburgh, and I researched and co-discovered the dinosaur footprints here at Prince Charles's Point. And this is the story behind those footprints. Our story begins 167 million years ago in the Middle Jurassic period, a time when Skye emerged as a newly formed island in the early Atlantic Ocean. On that island, tall mountainous peaks were drained by powerful rivers, meandering and sweeping across the land, emptying into these huge river deltas, fringed by mudflats and lagoon margins that were teeming with dinosaurs.
To me, the most striking thing about the fossils we see on Skye is that they reveal just how different Scotland was back in the Middle Jurassic than it is today. We all know Scotland today, especially those of us that live here. We know what the climate's like, we know what the weather's like, we know about the rain, we know about the high latitude and how dark it is in the winter, and you know, we feel this stuff, we live it. But back in the Jurassic, Scotland was just so different. This was a time roughly between about 180 and 160 million years ago, give or take. And it was like parts of Spain or parts of California today. It was a subtropical, quite lush, verdant environment. It was part of an island. That island was in the Atlantic Ocean, really just a narrow seaway at that point. And by this time, dinosaurs, they spread around the world to more places. They grew in size. You had the big meat eaters, big long neck dinosaurs, stegosaurs with the plates on their backs, and so on. So much of that underpinning of dinosaur evolution was happening in the Middle Jurassic. And that's a little bit frustrating, though, because we don't have a whole lot of fossils of that age. And that's where the Isle of Skye turns out to be quite important here in Scotland, because it has rocks that are full of fossils right from that Middle Jurassic age, and they help tell the story of how dinosaurs were evolving during this time.
And Prince Charles's Point is very much part of that story. And surprisingly, it wasn't until 2019 that we found the first footprints here. It was on an autumnal August afternoon that I was wandering along the shore with local Gaelic singer Anne Martin, visiting student Victoria Bradder, and Dougal Ross, the curator of the Staffin Museum, when we found the first few footprints.
I remember that day we went to Prince Charles Point at Kilmuir. We discovered 3 amazing theropod footprints that day. And from there on, Tone went on to identify 131 in total. Being a local, it gives me a lot of satisfaction that these footprints are being found. It's so close by. It's really awakened the attention of not just the academics, but also local people are showing a keen interest.
To see these, I mean, it's amazing. Just gives you an idea of the kind of bulk that would have 1 foot there. I can't even reach that one with my other foot. Oof. And then in there. I mean, huge animal. You can kind of feel like we've been shuddering. There is something very beautiful about the fact that these footsteps have been here, unbeknownst to us all.
Yeah.
And I keep thinking about, like my grandparents' generation and those that were here before, or even, Bonnie Prince Charlie appearing on the landscape here, and with no knowledge at all of what had gone before. And I find that quite breathtaking.
And there it is, just down here. The one.
That's the one, which I love to bits. And it goes right underneath there. And then Dougie just picking up this stone and revealing that middle toe, which goes right, it's really long, wasn't it?
Yeah.
That was amazing, finding it that day.
Yeah, you're right
With
about that. And with so many footprints scattered across the site, we needed to document them, not only on the ground, but also from the air above. To achieve this, I enlisted the help of colleagues from the University of Edinburgh in April 2023. They included paleontology master's students who helped by clearing many of the footprints of sand and water, as well as taking important field measurements such as bearing. Alongside them were drone technicians Tom Wade and Craig Atkins, who set up the ground survey stations to relay precise GPS coordinates to their trusty drone. Its mission was to photograph the entire track site for the first time and allow us to use those photographs alongside those taken by hand to digitally preserve the footprints as 3D models for current and future research. With the tide at bay and a vast area to cover, it was time to commence our 3.5-hour photo shoot.
I think the zigzag covered it, but like not a lot of the...
I was just in that little corner there.
Yeah.
There we go.
By overlapping the photographs, we could then use specialist software to digitally reconstruct the track site and allow us to see the footprints as never before. It's through these models that we can peer into the past and produce site blueprints, mapping out the many pathways of the dinosaurs that once roamed here, preserving those brief moments in time. Now, one of the things which I observed at Prince Charles's Point on our site blueprints and as well in the field is the variety of directions to which our dinosaurs travelled. This is something that is particularly important because it tells us about the local geography of the area. We can visualise the direction of travel that these dinosaurs went in what's called a windrose diagram. We can see the theropods represented in the red and the sauropods in the blue, They're all going in a manner of directions. But what's interesting in that diagram is that none of the dinosaurs appear to have travelled to the southeast. Now we could speculate that in the southeast there was some sort of obstruction preventing them from travelling. Maybe it was deeper water. But because of a lack of wave-cut platform here, we can't really verify that, unfortunately. We can only speculate. But what's really exciting is that the random directions of these dinosaurs demonstrates that the lagoon margin which they traversed was a vast, wide, open space. A vast, wide open space that was clearly bustling over a short period of time prior to being buried. But what about the dinosaurs themselves? What exactly traversed this lagoon margin 167 million years ago? To find out, we need to look more closely at the finer details that make up these footprints. Today, I've invited back local Skye paleontologist Siobhan McFarlane to show her some of the dinosaur footprints we've uncovered. Hey Siobhan, how are you doing?
I'm good. How are you, Tone?
Yeah, it feels like we were only here literally just yesterday.
Yeah.
Ready to go looking for some dinosaurs?
I am so ready. Let's do it.
Okay, let's head this way. So what we have here is probably one of my favourite set of footprints at the location. It's this pair of crossing theropod tracks. Can you see the first trackway coming along here?
Yes.
It's kind of faint, but visible and sharp once you get your eye in. So you've got the one track maker on the right here, which has got much bulkier toes. And then we have the one on the left, which is much slender digited.
What tells us that these are theropods?
So the evidence that we have that these are theropods is of course the really sort of moderately slender free toes and the ferocious claw marks accompanied by these rounded bulges on the side, which are where the phalangeal pads would have been impressed. These pads that we can see here in our fingers, which were also in the feet of these dinosaurs, which would have housed these very powerful muscles that this animal would have used in combination with its sharp claws to claw its way into its prey. So
powerful dinosaurs.
yeah, not something you want to get on the wrong side of.
No, it doesn't seem like it.
Particularly at breakfast time.
So can we tell how tall these dinosaurs would have been?
We can actually measure the length of the foot here to estimate hip height. What we do is we measure from the base of the claw mark, where the toe ends, to the heel down here, and we can see it comes out at about 45 centimetres,
Yeah.
which if we multiply by 4 gives us an estimated hip height of about 1.8 metres, which is about as tall as our cameraman over here.
Wow. So do we know what kind of theropods made these prints?
When we compare this to other similarly aged tracks from around the world, North America, Europe, we find that they were made by probable megalosaurs. Megalosaurs were the precursors to T-Rex, sort of ancient ancestors, and they too would have been hunting those pesky herbivorous dinosaurs.
So very much meat-eating dinosaurs.
Oh yes, that's for sure.
There's decent odds that the big three-toed tracks were made by an animal like Megalosaurus. They were certainly made by a meat-eating theropod dinosaur. Those are the only types of dinosaurs that have those type of feet. Megalosaurus was the very first dinosaur given a formal scientific name back in 1824 when some of his bones were found in England in the Middle Jurassic. It was, for its time, a pretty big meat-eating dinosaur. It would have been an apex predator, top of the food chain. It was a local dinosaur at that time that the Skye footprints were made. It seems to have been a pretty common dinosaur, at least in what is now England, which would have been very, very, very close to what is now Skye. And the size of Megalosaurus is roughly the size of a Jeep or a really big car. That size fits the size of the track. So all things considered, Megalosaurus, or a really close relative, is probably one of the most likely track makers.
But the theropods weren't the only dinosaurs roaming this ancient lagoon margin. So the other type of dinosaur that we have here at Prince Charles's Point are these very flat and rounded footprints. Some of them have got toes, but most of them don't. These are the footprints of sauropods, these long-necked dinosaurs, plant eaters that would have fed on trees that were tens of meters tall, taking advantage of a niche that other dinosaurs couldn't. And here we've got a trackway of about 8, a left-right stride going along here.
It's very rhythmic pattern.
Yes,
It's been left.
And the footprints, although this one looks fairly regularly shaped, it's actually irregular. You can see here, it sort of widens here and then narrows in towards the heel down here. And some of these even come with their own toes and claw marks too, which is really, really cool. Sort of veering off to the side or facing forwards. And on rare occasions, we can see a crescent-shaped handprint with a sort of big thumb digit called the pollex sticking out to the lower side.
Why is it that we don't see any handprints here?
So this dinosaur overprinted its handprints with its hind prints, these big, large, circular ones. We do see them, or hints of them occasionally, maybe in that one there, we can see like the hint of one.
There's a little bit more, yes.
Yeah, you see it, there's a bit of a crescent sticking out here, a very compressed one at that, that's been squished by this big footprint here. But one of the things that sort of struck me when I first saw these is that these are incredibly flat, right? They're not really deep. You imagine sauropods as being these really heavy, lumbering beasts, and you just sort of imagine them punching through the different layers of sediment at the time. But no, these are like discs. You know, they're really flat.
Very shallow in comparison to the other prints that we've seen.
And as it turns out, the cause for such shallow footprints lay just centimetres below the dinosaur's feet, a layer of hardened mud. So whenever a dinosaur walked through, rather than sinking down, their feet caused the overlying layer of sand to spread horizontally across the mud, to then exude upwards and form these onion ring-like structures called displacement rims around each footprint.
Forcing this out from the prints.
Yeah, almost forming like a little mini crater in a way, but that feature is gone. But we do see it in other footprints at the locality, where you can see these ripples running across the surface of that mound.
I was just wondering about the speed, because these are so close together. And when you think about how big and heavy this animal was, it's like it's barely moving.
Exactly.
compared to the theropods.
This animal would have been much bigger than our theropod, probably reaching about 15 or 20 meters in length. When it comes to the speed it was moving at, we multiply the length by 4 to get a hip height of 2 meters. We can then in combination measure the distance between each footprint in the stride and then put it into an even fancier equation. We find out that this dinosaur was moving at about 0.69 meters per second.
Oh goodness.
Is about half the average human walking speed, which is about 5 kilometers per hour.
Sounds like a very gentle dinosaur.
Oh yes.
Very slow pace.
It was very relaxed. It wasn't in a situation of any danger. Of course, all around us, in fact just behind you, there are some theropod footprints making a beeline towards these sauropods. So this dinosaur could have been on the trail of them.
Is it another single animal travelling, or is there multiple animals?
So it would have been an individual. We know that these animals walk in their own direction. They don't seem to follow one another.
They're quite confident hunters.
Yes.
They don't need to hunt in a big pack as such.
They were solitary at the time.
Okay.
But whether they hunted in packs remains to be seen.
Yeah. We need to find more tracks
Yeah,
to tell us.
Exactly.
Yeah, the sauropod tracks to me are really intriguing because when I moved to Scotland and started my job here at the University of Edinburgh in 2013, there were some bones of sauropods that have been found on Skye, including that limb bone that was one of the first 2 dinosaur bones ever found in Scotland. But nobody had reported their footprints from Skye. And then a few years later, when Tom Challens and I were out at Duntullum, it dawned on us there that these tide pools were made from dinosaur footprints. Seemed to be a sequence to a lot of them, a left-right zigzagging sequence. And then we looked closer and these things were big. They're about the size of car tires, but they weren't just round circles. They had some shape to them. They had little bits sticking off one end that really looked like the impressions of toes. And now we know what to look for. We know that these big, fairly circular, but sometimes slightly off-circular holes in the rock in the tidal zone could be dinosaur footprints. So now at Prince Charles's Point and other places, we've started to recognize more of these sauropod tracks, and it does seem like they're more common in the lagoonal rocks, these rocks that were formed in very, very shallow water or at that interface between water and land. They're not really so common, or not really at all, in like the mud rocks that were the mudflats or a little bit, farther from the beaches. So I think that's hinting at some kind of environmental preference for these different dinosaurs. We can start to envision that the long-necked dinosaurs seem to have enjoyed living more by the water, wading around in the shallow water. And the stegosaurs and the duck-billed dinosaurs and so on maybe were a little bit more land-bound. But, that's just a hypothesis. It's a theory. We got to test it as we continue to find more dinosaur tracks, and that's why we're always out looking for more fossils.
Thanks to our research, we now know that large megalosaurs and sauropods once roamed across a shallowly submerged lagoon margin, set in the heart of this vast river delta spanning as far as the eye could see. With all this in mind, imagine that you're just standing on this spot, surrounded by these footprints and ripples 167 million years ago. It's dark and the sun is slowly rising.
As you breathe in the warm, subtropical humid air, you feel refreshingly cooled as the shallow lagoonal waters lap around your feet. Through the fine early morning mist, you'd only see as far as a thin sliver of lagoonal shoreline. Dotted along it, the ghostly ashen silhouettes of conifers and tree ferns, as well as half a dozen sleepy long-necked sauropods, munching on the tall foliage and venturing out once more into the lagoon margin where you stand. Gradually, the sauropods' necks rise with the sun, as the vibrant colour shimmers the remote subtropical landscape. As the mist thins to a fine wisp, a vast network of lagoons and vegetated islands open up around you, each with their own early risers. One of them, a lone megalosaur, the local apex predator. It traverses across the lagoon margin, eyeing up its next meal as the sun catches its razor-sharp teeth. The lagoon plain now stretches kilometres in either direction, enclosed either side by spectacular forested uplands, floating on the receding mist as the dinosaurs left their footprints once more. And although we'll never get to see the dinosaurs that left these footprints, what we do have is a valuable record of their existence in Scotland during the Middle Jurassic. It just goes to show that you never know where the next great dinosaur discovery might lie. Right, let's go look for some more dinosaurs.